Lesson 6.8 is a study of the standard form of an equation. This is the second equation form that we're learning in Chapter 6. The first one, which we spent all of our time on, is slope-intercept form, where the equation is solved for y. With standard form, the equation has x and y together on the same side. So the equation form is ax plus by equals c. X and y are together, and there's a constant number on the right side. Three vocabulary terms that we will look at: linear combination, standard form, and oblique. There are three main reasons why standard form is beneficial. Number one, many real-life situations can lead to standard form, just like slope-intercept form. So there are word problems where an equation in standard form makes more sense. Reason number two, you might recall from slope-intercept form that you cannot write a vertical line equation in slope-intercept form because the slope is undefined. But standard form can be used to describe a vertical line. So when you have a vertical line like x equals 8, that can be written in standard form, but not slope-intercept form. And then number three, standard form gives the x and y intercepts. So we'll review the 0, 0 method. That's really the main benefit of standard form. You can find points very quickly and graph your line accurately by using the intercepts. So let's take a look at number 3, which involves this equation of 3x plus 12y equals 24. So we could graph this line by using two different methods. Let's look at 3a. It says find the x-intercept and the y-intercept by plugging in 0 for x and 0 for y. That's what you might remember as the 0, 0 method. So if I do that, it looks like this. 3 times 0 plus 12y equals 24. So I'm left with 12y equals 24. Divide by 12, and y equals 2. So I know that one of my points is 0, 2. Do the same thing, plug in 0 for y. And so I'm left with 3x equals 24. Divide by 3, x equals 8. So my other point is going to be 8, 0. So what I did there was I used the 0, 0 method. I plugged in 0 for x and 0 for y. I found the intercepts. So the points are 0, 2, and 8, 0. And then if I graph that, you'll notice that so when I actually graphed that, I had the wrong graph on there, but the right graph comes from using my two intercepts, which we said are 0, 2, and 8, 0. So I plug those in right here. There's 8, 0. There's 0, 2, and you can take your straight edge, and you can draw your line right through there. So there would be your line for the equation 3x plus 12y equals 24. We used the 0, 0 method, found those 2 points. Now the other thing you could do is you could rewrite the equation in slope-intercept form, which we have done before. So you might find this easier. Start with 3x plus 12y equals 24. Take away 3x from both sides. You're left with 12y equals negative 3x plus 24. divide everything by 12. Y is equal to negative 1/4 x plus 2. And if you look at your graph, you should see that the y-intercept matches. That's what we had found with the 0, 0 method. And if you use rise over run, you also can determine that your slope is accurate. So there are two methods basically for taking standard form and graphing it. And so on the notes here, 0, 0 method, which I showed you the work for, and rewriting it in slope-intercept form. And you should have that work shown in 3A and 3B. We continue on with the notes. Number 4. An expression of the form ax plus by equals c where a and b are fixed numbers is called a linear combination. That's what goes on the blank right here, linear combination. And that's the idea with standard form. You have x and y together, and so you have basically a combination on one side of the equal sign. So we call that standard form of an equation. The equation ax plus by equals c, where a, b, and c are constants, is the standard form of an equation. So those are two very important vocabulary terms: linear combination, standard form of an equation. So let's take a look at example 2, which involves rewriting y equals negative 4/7 x plus 9/7 in standard form with integer coefficients. So right now we have slope-intercept form where negative 4/7 is the slope, 9/7 is the y-intercept. And we have fractions, and we want integer coefficients. And then we're going to identify the values of a, b, and c. So the first step is we want to clear the fractions. So this goes back to an earlier lesson we had, chapter 3. I'm going to multiply everything by 7. So what I'm left with is 7y equals negative 4x plus 9. So you might recall the lesson on clearing fractions. Multiply everything by the common denominator. In this case it's 7. And so 7y equals negative 4x plus 9. I'm going to divide everything by 7. So I have y equals negative 4x plus 9/7. And that gets me right back to slope-intercept form. Well, this example is not saying take the integers and put it into slope-intercept form, but it wants standard form. So this is not what we want to do right here. What we have is 7y equals negative 4x plus 9. We want it in standard form. So this is the opposite of what you would do for slope-intercept form. So what we're going to do is we're going to add 4x to both sides, which might seem strange to you. Standard form then is 4x plus 7y equals 9. And that's actually my final answer. It's different than slope-intercept form. Instead of solve for y, x and y are together. What are my a, b, and c values? A is 4, coefficient of x. B is 7, coefficient of y. My constant is 9. For example 3, I have y equals negative 0.75x. So that's in slope-intercept form. It wants standard form with integer values of a, b, and c. Easy way to multiply to get this into integers. Move the decimal place 2 places to the right. I'm going to multiply by 100. So that gets me to 100y equals negative 75x. All I did was multiply by 100 because I want to move the decimal place twice to the right. So now, to get standard form, I'm going to take this term and send it over to the left side. So I'm going to add 75x. So correct standard form is 75x plus 100y equals 0. So what are my A, B, and C values? A is 75, B is 100, and C is 0. Final 2 points here on the notes involve number 9, the last vocabulary term. Lines that are neither horizontal nor vertical are called oblique lines. And those are typically most of the lines that we deal with, and we have seen that oblique lines can be written in both slope-intercept form and standard form. One of the benefits of standard form is that every single line can be written in this form. So if I have the equation, which is vertical line, x equals 4, that cannot be written in slope-intercept form because the slope is undefined. It could be written in standard form, and it would be x plus 0y equals 4. And you should be able to see that x plus 0y can be simplified into x equals 4. A horizontal line example would be y equals negative 3, and that could be written as 0x plus y equals negative 3. That might seem a little confusing to you, but if you notice, it can be simplified into y equals negative 3 because 0 times x is 0. So vertical lines and horizontal lines can be written in standard form, and that's one of the benefits of learning this idea of linear combination where x and y are together on the same side of the equation.